This is Mrs. O'Neill for AP Chemistry, Chapter 16, Section 5, Strong Acids and Bases. In this chapter, you're going to categorize if an acid and a base is strong or weak, and understand that strong acids and bases are strong electrolytes, and they'll dissociate completely in an aqueous solution. You're also going to learn that weak acids and weak bases are weak electrolytes, and they ionize only partially. This is information you already know, but now we need to put it into mathematics. We need to understand the math behind it. Lemons and grapefruits have a sour taste because they contain citric acid. Sulfuric acid is a widely used industrial chemical that can quickly cause severe burns if it comes into contact with skin. You will learn why some acids are weak, like your fruit that you can eat, and some are very, very strong, like sulfuric acid, and it can burn you. So here's a list of relative strong and weak acids and bases, and it goes in order. That's why I like this. You have your very, very strong acid of HCl goes to your weak acid of hypochlorous acid. They don't label the water, but that would be a neutral solution. To your weak base of ammonia, to your very strong base of potassium hydroxide. So I like this visual to show you how it goes from strong acid, neutral, weak base, strong acid. So we want to keep in mind that range, just like the pH scale. So at this point, pause the video, fill in the blanks in your notes packet, and then play to hear my words. So we want to remember that the stronger the acid, the weaker its conjugate base. So we want to remember that a strong acid means that the reaction lies to the right. In other words, if it's a strong acid, it's going to basically go to completion. Versus a weak acid, the reaction is going to be in equilibrium, and probably the reaction is going to lie to the left, where you have more of those acid molecules. So if you have the same thing with the base, a stronger the base, the weaker the conjugate acid. So again, you need to memorize these. You should already have them memorized from Chapter 4. So what does a strong acid do? It 100% dissociates. So we have that one arrow to show you that that HCl is going to break up apart into H plus and Cl minus. So you can also look at it this way. Sometimes they include that water so that hydronium ion is balanced in the equation. That's really the only purpose of putting in that water in the reaction, is just so that it's a nice balanced equation. So you want to remember that it goes to completion. It is not an equilibrium, so the HCl goes all the way across. So the H plus concentration is going to equal the anion concentration, right? And that should make sense because there's no HCl involved. So if you have 0.1 molar HCl solution, that means you're going to have 0.1 molar H plus and 0.1 molar of Cl minus. And it's really nice when all the coefficients are 1. But if it's not 1, like we saw in the last section, you're going to have to multiply it by that coefficient. So strong acids, again, they usually, same as strong acids, strong bases are the same as strong acids, and you're usually calculating OH minus or the POH and then converting it to the pH or the H plus concentration. Again, you just saw this in the last section. So again, interpret this graphic, make sure you can understand what it's telling you, and see if you can answer these questions. Again, read that over. Hopefully that makes sense to you. So give it some thought. So if you look at the balanced equation, if you look at that they're both strong, so they both go to completion, so the amount of molarity you start with in your base is going to equal the molarities of your ions, as long as they're all coefficients of 1. But if we look down here for barium hydroxide, we have a coefficient of 2 because it breaks up into 2 OH minus ions. So which solution is going to have the higher pH? Is going to be that guy, because he is stronger. So if you have 0.002 OH value, you're going to have a higher pH because that means you're going to have a lower H plus ion concentration, right? So the higher the pH, the stronger the base. Higher pH, stronger the base. Hopefully you're understanding that. And another, give it some thought. This one's a little trickier. Remember what we said in the beginning. The stronger the acid, the weaker the conjugate base. Read that over. Make sure it makes sense. Okay, see you in class.